Bonjour. Welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Bronwyn Slade. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View Channel 972. You are always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday, 10 until 11 in the morning, and we are in our third week of our 9-week course. At this point, you definitely should be considering handing some work in, but a reminder, the support questions, the ones with a little pencil icon, are not for marking. You decide which ones and how many to do. If you're understanding concept, it's totally okay to skip questions. You don't have to do them all just because they're there, but they are a good idea to do, so you want to make sure that you are actually completing enough work so that you're confident with your understanding. The answers are in the back of your booklet, so check your work. If you are struggling to understand something or you're making mistakes, that's a really great way to see if you're on the right track or if you should be asking questions, and I can support you and walk you through what it is that you're confused about. The key questions, however, are the mark questions. So do all of them, show all of your work, your steps, your thinking, and this way I can know what it is that you actually know. And if you're struggling with anything, then I can support you and help you to figure out what it is that you are doing wrong. So show me your work so that I have more information about what it is that you're doing. Then how do you submit your work for marking? Well, there's 3 methods. The first is to scan your work and send it electronically. If you have a device, you can scan your work using that device. Apple devices come with a Notes app that has a scan function, and Android devices have a Google Drive app that has a scan function. These are free apps, so if for some reason you don't have them, you can download them. And the scan's basically pointing and clicking. It's fairly straightforward. If you do need step-by-step help to do that, I have created videos on my YouTube channel under the Tech Tutorials playlist that show you how to actually go in and do this step-by-step. So go check it out there. Then you can send it to me through email to studentwork@nnec.on.ca and cc it to bronwyn.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students can also fax in their work, though it's a really good idea to give us a call to let us know that it's coming, as sometimes things get lost by the fax machine. If you want to connect with me through social media, both my Facebook and my YouTube channel under the name B. Slate Wahsa, you can friend me on Facebook or subscribe to my YouTube channel, and then you'll get notifications every time we upload one of our radio Zoom classes. They're all recorded and I'll load them to YouTube shortly after broadcasting. But there's also I have short little videos that I've made that explain common errors and confusing concepts that are on that channel. So it's a really good place to go and start if you are struggling with something. Math is a really visual subject, so I strongly encourage you to access the videos. This is really going to set you up for the most success and help you have the deepest understanding possible to have both the video and the audio. If you can't join me live for the Zooms or you can't watch the replays on YouTube, let me know and I'm happy to send you a copy of the recordings so you still get the full experience. So if you have any questions or concerns, please reach out and connect with me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is bslatewasa. My phone number at the office is 807-737-1488, extension 2209. You can also call us toll free at 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 until 11, so that is not a good time to try to get a hold of me. Today's lesson is lesson 7, and we are looking at compound interest and exponential growth. This is similar to what we've done in lesson 6, but a different type of interest. Our learning goals for today are that you'll be able to calculate the final amount when investment or loans interest is compounded, and you'll understand the relationship between compound interest and exponential growth. You know you've met these 6 criteria because you can identify the principal, interest rate, compounding periods, and time in order to find the final amount, and you can graph compound interest growth. When will you use this in real life? Well, we're making connections. Connections is something that is going to happen in your life no matter where you are, what you're doing. So being able to draw these connections and see how things in your life are connected is really beneficial. But before we dive into that math, let's activate our brain with some mental math. I don't believe in mad math minutes. They cause stress and anxiety, and generally, more often than not, do not help students learn. They just reward students who are comfortable with speed, whose brains work in a way that speed of memorization is successful for them, and many students that's not true. So instead, we work on developing strategies that work on comfort and familiarity with numbers so that students use the tools that they have. Our question today is 52 plus 49, and we're using the strategy of near doubles. So doubles, when we're adding our numbers that our brain is pretty happy with and likes. So it's pretty comfortable to add numbers together. So here we can see that we have 52 plus 49 is our question today. So 52 is really close to 50, and 49 is also really close to 50, and 50 plus 50 is 100. So that's great. But what we had to do was we had to add an extra 1 to 49 to get to 50, and we had to take away 2 to get from 52 to 50. So that means with 100, well, we've taken away 2, which means we need to add another 2 because we took those away, and we added 1, which means we need to take away 1. So adding 2 and taking away 1 is really just adding 1. So that's going to be 101. So 52 plus 49 is 101. And that's how we use near doubles to do addition. So let's turn our minds on and think about what prior learning we need for today's lesson. I just want to recap simple interest. Let me iterate, this is a recap. If you have not watched the previous lesson, the lesson on lesson 6, session on lesson 6, then go back and check that out so that you really know what I'm actually talking about. But this is just a refresher if we did that to remind you to get you situated. So our formula for simple interest was I equals PRT, where I is your interest earned in dollars, your P is your principal invested or borrowed in dollars, so the amount of money that you start with. R is your interest rate per year, and it's expressed as a decimal, and T is your time in years. Simple interest is only calculated on the principal, and it's linear growth. It grows at a constant rate. You increase by the same amount every single time period that you're investing for. That is simple interest. So let's take that and tweak it to explore some new concepts. This is also all the way around us. Compound interest is what we're focusing on today, and it is a way that money is invested and borrowed a lot in our world. So the stock market is uses compound interest like every moment. Credit cards use compound interest to calculate the interest that you owe them. Student loans, things like that, also calculate interest. So it's both investments and loans that really use compound interest a lot in our society. So first, before we dive into the formula of compound interest, I just want to connect how simple interest is different and can be sort of modified to compound interest. So let's remember what happens when $1,000 is invested for 7 years at 5% simple interest. We're using a chart to help us keep ourselves organized. In year one, we have a principal amount of $1,000, which means that we have our interest is 1,000 times 5%, so 0.05, so that's $50. And the amount then is 1,000 plus $50 is $1,050. Is how much money we have at the end of year one. So in year two, our principal amount is still $1,000. We still make an interest amount of $50, and now our final amount is $1,100 because we add $50 to our previous amount, which is $1,050. And this continues for year three, year four, year five, year six, year seven. Every year we are increasing our amount by $50. We're getting interest by that constant amount of $50 every year. And so we're just increasing by $50 every year. So after 7 years, we have a total of $1,350, which means we earned $350 in interest. We started with $1,000. Now we have $1,350. So that extra $350 is the interest that we've earned. All right, so with the same numbers, what happens when $1,000 is invested for 7 years at 5% interest compounded yearly? So we have to see how this is different. So again, let's look at this chart. Year one is the same. We start with a principal of $1,000. That means we make $50 in interest that year. And at the end of the year, we have $1,050. Year two is when it starts to change, because now our principal is different. Compounding means what we've done is that we're going to now earn interest both on our principal, that $1,000 we started with, but also on the $50 that we earned in interest. So now we do 5% of $1,050, which is $52.50, and we add that for our amount to the $1,050. So now we have $1,102.50. So in year two, now all of a sudden we have $2.50 more than we did if we were just doing it in simple interest. You're like, whoopee, that's not very much, but let's keep going. Because of year three, now our principal, again, is different because we invest all of that interest that we just earned. So our principal is $1,102.50, which 5% of that is $55.13. So now all of a sudden we're earning more interest than just that $50, right? That's increased. So we add that to our amount, and now we have a total of $1,157.63. And this continues. For year four, that new amount is our principal, times it by 5%. So our interest amount for this year is $57.88. So add that to our $1,157.63, and we have $1,215.51. Year five, we now have $1,215.51 as our principal. So 5% of that is $60.78. So add those two together and we get $1,276.28. In year six, that final amount that we had is our new principal. We multiply by that by 5% and get $63.81. So add those two together and we get $1,340.10. And After year 7, we now 5% of $1,340.10 is $67. So add those two together, we get $1,407.10. So after 7 years, we have a total of $1,407.10, which means this time we earned $407.10 in interest when we were doing compound interest. So let's compare two situations on the same slide to really see. So remember, after simple interest, we had a total of $1,350 in the 7 years, which meant that we earned $350 in interest. And after the compounding example, we had a total of $1,407.10, which means we had earned $407.10 in interest. So if we look at that, we have $57.10 more just because of the compounding interest. We didn't do anything different. We didn't have to, the bank does it all. We don't have to do anything different as an investor. We just have to recognize the difference between simple interest and compound interest and see that just by that interest amount being reinvested means that we make a little bit more money. This isn't a ton more money in this example, but we made a little bit more money, which if you're investing is the goal. So the thing is with compound interest is that at the beginning, there's not too much of a change. If you do it for a long time, it is significantly different. So on this diagram that I have on the screen, we have our principal is $1,000. So this blue chunk here at the bottom is how much we're investing. So that's the money we already have. Okay, that's like our baseline. The red section is if it's simple interest. So just going up at that constant rate. And the green section is the compound interest. So you can see after 1, 2, 3, 4 years, there's not very much difference between the red and the green parts. They're still very close. But as we continue, after 20 years, there's this huge difference between the red and the green parts. How much? So the red only goes, the simple interest only goes up to $3,000. So you've made a total of $2,000. But the compound interest is now over $7,000. So that means you've made over $6,000 in that same time frame. So it's 3 times the amount just by compounding that interest over and over again and making money off of the money that you already made. So this is why compound interest is so significant when it comes to investing, because this long-term investment makes huge gains. So this, you can see compound interest is exponential growth. Like we've looked at those exponential functions in lesson 5. This is the same thing. Our compound interest grows at an exponential rate. So compound interest, to remember, is the interest calculated on the principal and the earned interest or the accumulated interest, the interest that you've already, as you make it, you invest it again. It's exponential growth, like we just saw. And I like to think about it, it's free money from free money, right? Because investment earns you interest, is money that your money has earned you. And then as you invest that interest more and more through compounding, you get more and more money. So you haven't have to do anything with money that you've had to earn. The money makes the money. But the key to remember is that this is really great for investments. If you are investing money and you are getting the interest, this is awesome. But it is awful. It is not helpful at all if you are borrowing money. If you are borrowing money and you have compounding interest, that means that you are paying more and more, right? Because that interest shows the amount of money that you're paying, and you don't want to be paying interest on interest. That's not good. So that is a trick to be paying attention to. So then I like to ask, well, can we get more free money? We know that compound interest we just saw earns us more interest than simple interest, but can we get more than that? So the more frequent we compound, the faster the interest adds up. So the more time we reinvest that money that we've been investing, so the principal and the interest, the more frequently we do that, then that means the faster the interest adds up. So let's look at this on our graph. We have, if we invest for 1 year, and I've just used low amounts, we can see that this red line here at the bottom is our compounding interest. So simple interest would be a straight line, and it would probably veer off like here. But compounding, we can see it curves at a pretty slow rate, but it curves. So it's still exponential. Great. But if we do it by months, which is this blue line, again, just at the beginning, it is not very frequent. It doesn't show you a lot. Then it goes up more and more and more, faster and faster and faster. Weeks is this green line. So the green line also goes up faster and faster, faster. And days is this yellow line, goes up faster and faster and faster. So the more frequently we invest, the better our investments are. The more money we're going to make. More frequently we compound, sorry. Anyway, so let's look at compounding frequency a little bit more. So this is the compounding period, means the time frame in which compound interest is calculated. So this is key to understand for this. Compounding periods are less than a year. I don't know if they ever are more than a year, but that is not to our benefit, right? We don't want it compounded longer, we want it compounded shorter. So from my understanding, they all are less than a year or a year. So when we know what the compounding frequency, we need that translates into a number of periods per year. So annually would be the compounding frequency, means once per year. Semi-annually means twice per year. Quarterly means 4 times a year. Excuse me. Monthly is 12 times a year. And weekly is 52 times a year. And daily is 365 times a year. So hopefully that's logical of where those numbers are coming from. So now let's dive in and look at the compound formula interest. And this is, sorry, compound interest formula. My bad. This is on page 9 of your IEL booklet. So this is sort of where your booklet starts talking about this, whereas I gave you a little bit of a background to understand where it came from. So a tricky thing is that if you have a copy of an old booklet, so before 2021, there was an old formula in those booklets, which still totally 100% works, but it means you need to do more thinking and organizing before you put your numbers into your formula, and that can get confusing. So we're just going to quickly look at that old formula in case you have that old booklet, and then we're going to look at the new formula that I've updated, and hopefully most of you have. So this old formula is A equals P times 1 plus I, and the 1 plus I is to the exponent n. So A is your final amount. P is your principal, which is the invested or borrowed money, the amount of money that you start with. So I is your interest rate as a decimal per compounding period. So how you figure that out, so this is a small I in your formula, and how you figure this out is that you do your interest rate as a decimal, just like we did before, but now you need to divide it by the number of compounding periods that you have per 1 year. So that compounding frequency you need to divide it by. And then n is the total number of compounding periods. And to figure this out, you need to do the number of compounding periods per 1 year times the total number of years. So with the simple interest, we always need it to be in years, but here our n is our number of compounding periods, not our number of years. So it's how often we compound in total for the total life of the loan or the investment. So then if you have a new booklet, so from 2021 to 2022 school year or from 2022 to 2023, this current school year. Hopefully you have an updated booklet, because their formula, though it looks more confusing, has those tricky parts built into it. So the formula is A equals P times 1 plus R divided by N. And that 1 plus R divided by N is in brackets to the exponent of N times T. So here, A is your final amount and P is your principal invested or borrowed. It's the same as before. That hasn't changed. But R is your interest rate expressed as a decimal. So it's just the rate. You don't. And then the N is the number of compounding periods per year. And then T is the time in years. So let's compare the two formulas so that you can see how they really are the same thing. They just look slightly different. So A, the final amount, is totally the same. P, the principal invested or borrowed, totally the same. Then R is our interest rate expressed as a decimal divided by N, which is the number of compounding periods in our new formula. But in the old formula, they just called it I, and that was interest rate as a decimal divided by the number of compound periods in 1 year. So it's the same thing. It's just that I've written out explicitly in the formula. That's what has been updated to make it more accessible. Whereas in the old formula, that information you had to remember in the background. Then in your exponent, you have N times T, which is the number of compounding periods per year times time. And in the old formula, it was just N, which is the number of compounding periods times number of years. So it's the same thing, but once again, that was just had to do it in the background, whereas in the newer formula, it's explicitly written out there so that you don't have to remember that. So it's trying to mean that you're more just applying what you know, opposed to having to memorize information. Okay, so let's look at this with some real numbers and see what we actually get. So the amount of $4,000 is deposited into a savings account at a rate of 7% compounded monthly. Calculate the total balance after 5 years. So we're going to walk through step by step what it is that we do and how we know that this is a compounding question. So first, I like to write out all my variables so that what I know and what I don't know, so that I can figure out what it is that I'm looking for. So A is what I'm looking for. It tells me to calculate the total balance. A trick to remember is that simple interest, we calculated the interest and then we had to add it to the principal to find the amount. Compound interest, you are calculating the total amount to start with. So you're including that principal that you are investing. That's already built into the answer. So it's different than simple interest. So just pay attention to that detail. All right, so our principal is $4,000. Our rate is 7%, so 0.07. Our N is 12 because it's compounded monthly. This question says that it's compounded monthly. All compounding interest questions have to tell you how often they're compounded. So that's how you know. It'll say compounded, whatever, monthly, daily, weekly, yearly, annually, but it has to tell you that it's compounded, and that's how you know that you're doing a compound interest question. So compounded monthly, we need to translate that into a number. So that's 12 times a year. And then T is equal to 5 because it's 5 years. Then we have our formula. I also like to write down my formula every time to help me remember it and to make sure that everything goes in the right place. When I'm marking, if you have the formula written down and then later on you make a mistake, I know that you started off in the right place and then you just made a calculation error later on. And that just gives me a lot of information about what you understand. So A equals P times 1 plus R over N to the exponent NT. So then we fill in all of our variables that we know. So A, we still don't know, so we leave it as A, is equal to 4,000, open a bracket to times 1 plus 0.07 divided by 12, close a bracket, and then to the exponent, 12 times 5. So then you can simplify that. A note, if you have, if the decimal is more than 5 places in your calculator, it is best to keep that number in your calculator and do the calculations if you can, to get the most accurate calculation. If you round it off, if you write it down and round it off, then you're going to get a rounding error. I am not going to mark you wrong. I'm going to notice, like, look and say, okay, that's probably a rounding error, and give you the benefit of the doubt. But just in terms of accuracy, if you don't have financial things, all those decimal places do have an impact over time and as you do multiple things with it. So just something to be aware of. So then if you do that math, all that math, you get a total of $5,670.50. So the total balance of the savings account after 5 years would be $5,670.50. And that's how you do a compound interest question. Again, compounding is great for investments, but also applies to loans and debts. And as the individual, they're not so great then. So that's that kind of example. So number 2, Xavier's credit card balance is $800 at the beginning of July with an interest rate of 19.99%, compounded daily. He forgot to pay his bill until the next month. How much interest did he have to pay? So we're assuming that he didn't put any more, make any more purchases on his credit card. We're just leaving the balance as one thing. Credit cards are a little bit tricky because you can make purchases as things are also sitting there, but just we're going to assume that Xavier just had that $800. So first, the question is asking at the end, it says, how much interest did he have to pay? So we are looking for interest, which means that we have to do the total amount, which is equal to the principal plus interest. So that's what we're looking for. So we need to do all the other work, but we also need to remember that we're actually just looking for the interest, not the total amount. So our principal is $800. Our interest is 19.99%, which is equal to 0.1999. Our N, our compounded frequency, is compounded daily, so 365. Our T is a little bit tricky because it is for the month of July, which there's 31 days in July, but it's still per year. So we have to do 31 days out of 365 days, opposed to if we just did 31, it would think that it's 31 years. So that doesn't make any sense. So we're going to use our formula. So then we fill in what we don't know, or sorry, what we do know. A equals 800 times 1 plus 0.1999 over 365, all to the exponent 365 times 31 divided by 365. So they can get a bit awkward when you're writing them out, but this is why writing down all the pieces that you have is really helpful to keep you organized. Then we have, if we simplify that, we ended up with 800 times 1.00054 to the exponent 31, which is equal to $813.69. Have we answered the question? Nope. We have to remember that we're looking for the interest. So A equals P plus I. So that means that I is equal to A minus P, right? Our amount to take away our principal leaves us our interest. So we have I is equal to $813.69 minus $800. So $13.69. 69 cents. That's just a typo. So Xavier has to pay $13.69 in interest for the credit card balance that he carried in July. So that's why compound interest isn't great, because you end up having to pay more interest. If he didn't pay this off in July and he carried it for another month, then it means that he'd be paying interest on the $13.69, which isn't good. All right, so now we're going to look a little bit more at the exponential growth part of compound interest. So a principal of $250 is invested at 12% compounded for quarterly for 6 years. Calculate the accumulated interest at the end of each year. So we're looking for the interest, so amount to take away principal. We've got our compound interest formula. Our principal is $250. Our rate is 12.5%, so 0.125. Our N is 4 because it's compounded quarterly, and our T is 6 because it's 6 years. And because we want it at the end of each year, we're going to change this to just be T. We're going to be changing that as we go. So that's a little bit different. So for each year, we're going to do our calculation, but we're going to leave the T as just T for our time because we're going to change that depending on the year. So then we're going to organize this in a chart. And so year one, we do $250 times 1.03125 to the exponent 4 times 1. So that amount is $282.75. And then remember to find I, which is what we're looking for. We are going to take away that $250 to just remember what I is. So in our second year, we do the same thing, but now our T is 2. So 250 times 1.03125 to the exponent 2 times 4, which is $319.79. So our accumulated interest is now $69.79. And then we can just keep doing this for year 3, 4, 5, and 6, where we're just increasing our T value one by one so that we can see the pattern that's emerging. So now we're going to draw this on a graph to show the growth of the investment. We're comparing the years to the accumulated interest. That's what we want to see, just the growth. The investment, the principal is the same. That $250 isn't really changing anything for us, so we just want to see how much it grows. And here you can see on the chart is that you can see how this interest grows, accumulate every year. You get more and more interest, and that has that exponential growth. Once again, you can do this on Desmos, which is a free graphing calculator that is has an online platform and has a Apple and Android free app that you can download, which can be really useful to have a graphing calculator to just even check your stuff to see or to help you make sense of things. It's a really great tool that's fairly straightforward to use. Let me know if you want me to help you learn how to use it if you're struggling with it. You can use it and then sketch your drawings based off of what you were able to figure out on the graphing calculator. It's a great way. So C, use the graph to determine when the accumulated interest is $100. So looking at our graph, we can say, okay, where does 100 happen? And we look at where that hits our graph. And from there we go down, and that happens at 2.75 years, 2 3/4 years is when the investment has accumulated $100 of interest. So it's just another way of using the information that we have to find out another information. Now you can do the support questions on page 13, questions 1 through 3. All right, so we have a little bit of time to do some practice questions. Number 1, if a person borrows $2,500 at 5 3/4% for 7 years compounded annually, calculate the loan at maturity. So how much is it you're going to owe in total at the end of that time period? So that means that loan maturity just means at the end. So it's saying calculate how much you owe at the end, which is both the principal and the interest. So that's our A. That's what we're looking for. So our principal is $2,500. Our rate is 5 3/4%. So that's 0.0575. Our time is 7. And our N, our compounding, is 1. It doesn't matter what order you write down your variables. You do whatever makes sense for you, and you can do a different time, like as long as you're doing it and getting the information accurately. There's not a perfect way to write down the order of variables. So our formula is A equals P times 1 plus R over N to the exponent NT. Again, you can look this up. You don't have to have it memorized. I just do because I've done it so often, but that's fine if you don't. So 2,500 times 1 plus 0.0575 divided by 1 to the exponent 1 times 7. Now, the way that I like to do this is I like to put it all into my Desmos calculator at once. It just works well for me to do it all in one step. Even if I was using a scientific calculator, I would do it all in one step. But you don't have to if you don't want to. Again, you can do it what way makes sense for you. You just want to make sure that you're getting the same answer that I am. The tricky thing with Desmos is that if you have something in a brackets that has division, see, I want to close my bracket and how it just closes it on the bottom here. I don't want that. So I need to use my mouse or my finger if I'm using it on a smart device to move, or even the arrows to move my cursor over here outside the bracket and then close the bracket. That's a little annoying. And my exponent is a to the exponent b. And then 1 times 7. And so I get $3,697.45. $36.97.45. So it's a good idea to write a sentence at the end so that you know if you answer the question. The loan at maturity, you do not have to unless it asks you to, but it's helpful to make sure you've checked your answer, is $3,697.45. Is that more than what I borrowed? It is. So that looks like it's a reasonable number, that I didn't make a mistake on my calculations, because you can't trust your calculators to do all the thinking. They just do whatever they think you're telling it to do. Number 2, a person wants to invest $300 for 10 years and has 2 options. Which plan should the person choose? So plan A is 3.2% compounded semi-annually, and plan B is 2.7 compounded weekly. So one has a higher interest rate but isn't compounded as oftenly. One has a lower interest rate and is compounded more frequently. So we need to do the 2 situations, plan A and plan B, so that we can compare. So our principal is $300. Our rate for plan A is 3.2%, which is equal to 0.032. Our N is semi-annually, so semi-annually is twice a year, so 2. And T is equal, our time is equal to 10, because it's 10 years that they're doing. Sometimes you need to look around to find the information. So for plan B, it's also $300 for the principal. The rate now is 2.7%, which is equal to 0.027. The N is weekly, so that's 52, and the time is also 10. So our formula for plan A is 300. And as you can see, sometimes things don't line, like you run out of room, and so you need to move things around. I don't have a lot of flexibility on my screen, so we'll just make it do. So then let's calculate that using our calculator. So 300 for plan A, 300 times 1 plus 0.032 divided by 2 to the exponent 2 times 10. Oops, see how my 10 has jumped out of my exponent, and I don't want that. So I need to put it either in brackets like I did previously, or I can put the whole thing just in one set of brackets. So that is the thing with Desmos, is that you do need to be paying attention. But I like it because you can see it, so I can see the mistakes that I make. So that is $412.09. Be great if I put my decimal place in the right place, huh? $4.12 is really different than $412.09. So this is plan A. So plan B, this time I'm not going to write out my original formula just for the sake of space. So 300 times 1 plus 0.027 divided by 52 this to the exponent 10 times 52. The other nice thing with Desmos is that if you want to, if you're lazy like me sometimes, is that you can, I don't want you to do that. You can just change your numbers in here. So my interest rate and my compounding period are the only things that changed. So instead of writing the whole thing out again, I'm just going to change those numbers and then it's updated for me. So look at that is $392.96. So they should choose plan A because it makes them more money. We assume that when you're investing, you want to make more money. So plan A, it's only $20 more, but every cent counts, right? Number 3, Shuyin invested $750 at 5% per year, simple interest. Her sister, Shujin, invested $750 at 5% per year, compounded annually. Who earns more interest in 10 years? So in this question, we're comparing simple interest and compound interest. So again, you got to be paying close attention. So we have the sister Shuyin, and she's doing it for simple interest. So that means that we're going to be using I equals P RT, right? So P is equal to 750, R is equal to 0.05, 5%, and T is equal to 10 years. So we're going to put that in our formula, 750 times 0.05 times 10 is equal to and we're going to calculate this, $375. So the question just asks us who earns more interest. So this is already interest. So I'm not going to change that. I'm just going to leave it as interest. I don't need to know how much it is in total. I just need to know that that's the interest. So then her sister Shujin does the compounding interest annually. So it's still only compounded once per year, but how does that affect it for over 10 years? So we're going to do A equals P times 1 plus R divided by N to the exponent NT. So P is equal to 750 still. R is 0.05, same rate. N is 1 because it's compounded annually. And T is 10 because it's 10 years. So then we put those into this formula. And then we calculate it. Also, if never mind, I'm not going to say what I was going to say. So you can see I missed a decimal place. It's going to change my amount to a fair amount. So again, why I really like Desmos is because it shows me those things where I make mistakes. If your calculator doesn't show you have a screen like that, then that can be really hard. So that's $1,221.67. So when you first looked at this, you're like, whoa, Shujin makes so much more money. But remember, this includes the principal. So to find the interest, you need to do your total amount to take away your principal. because we're calculating two different things when we're comparing it. So we need to take away the $750 of the principal because they both have that amount. We're not comparing that, we're comparing the interest. So that's important. So it's $471.67. So that's closer to the simple interest, and it makes more sense. So you want to be paying attention because you wanted to make sure that your numbers make sense. We didn't make a mistake. We just weren't finished the question. So Shuzhen earns more. I don't know what that word is. Earns more interest. So if it asks us by how much more, we would need to subtract to figure out the amount, but we just need to know that that's all the question asks is who earns more interest in 10 years. So even with your compounding annually, you're still making significant more interest by compounding that annually, burning interest on the interest. Okay, we don't have time to do this last one, so let's consolidate what we've learned today. So compound interest grows exponentially, it grows really fast, right? And the pattern increases or decreases at a constant ratio. So we haven't talked about this too much, but that's what is happening exponentially, which we talked about in previous lessons about that being constant ratio, that we're increasing by the same amount each time. But for this, we just know that we're growing bigger and bigger and bigger every time. We use the formula A equals P times 1 plus R over N to the exponent NT. Remember, A is your final amount, P is your principal, R is your interest rate, T is your time, and N is your number of compounding periods. I also like this as this formula uses the same letters as the simple interest formula, so you don't have to remember two letters that are defined as the same thing. But then also your interest is found by doing your amount, your final amount to take away your principal, which is different than simple interest, which you calculate your interest first. So hopefully you can identify in a question the principal, the interest rate, the compounding periods, and the time in order to be able to use them and find the final amount. And you can graph compound interest using, depending on if you're comparing time to total amount or the interest, but you can figure that out. So if you have any questions with me, this is a little bit of a trickier one. So please let me know if you have questions and we can work through it. Understanding this is also key to understanding our next lesson. So if lesson 6 and 7 are giving you trouble, totally fine, but let's work on it together so that we can understand these lessons, and then moving on to our future lessons, we're setting ourselves up for success. Give me a call at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. Send me an email at bronwyn.slate@nnec.on.ca. Connect with me through Facebook at bslate Wahsa, or check out my YouTube channel at also called bslate Wahsa. Remember, all of our lessons are under the playlist called MBF3C, which is our course code. Thank you so much for joining me today. I hope this was a useful lesson for you. Miigwech.